GPUs versus CPUs. How are they different? First, let's talk about CPUs. CPUs are basically the general purpose processors that are good at doing everything. They are very small with an average of 4 to 16 cores. They are great at doing branching, like if-else logic, great at handling tasks that change a lot and can quickly switch between different kinds of jobs very easily. Some example of tasks that are usually handled by CPUs accomplish are like running Microsoft Word, web browsing, keyboard input, and running databases. Now let's talk about GPUs or graphics processing unit. They are basically chips that are more specialized for parallel processing tasks, meaning multiple jobs at the same time, which means it's good for graphics and large-scale mathematics. They are designed to have simpler and more cores in the hundreds or thousands, and they are built to have high throughput. Some strengths of GPUs include being able to execute the same instruction on a large dataset very fast, called the SIMD model, or the single instruction multiple data. And they are also much better compared to CPUs for handling 3D rendering and matrix multiplications required for machine learning. One simple analogy to compare CPUs and GPUs is that a CPU is like a very elite professor who's really good at solving complex and unique calculus problems, while a GPU is like a whole stadium full of college students just doing simple multiplications. Now let's go a little into the history of GPUs. In the late 80s and early 90s, computers had frame buffers which just stored images, and then in the late 80s, 2D accelerators appeared to assist with drawing basic shapes much faster. The first actual GPUs were introduced in the 90s, coined by NVIDIA when they introduced the GeForce 256, and the key feature of this technology was that it could not only move images, but can also compute geometric transformations and shading. In the 2000s is when 3D graphics became huge, and that's when NVIDIA introduced the GeForce 3, which introduced programmable shaders. In between the mid-late 2000s is when researchers started to realize that GPUs are actually the ultimate parallel computing devices and is really good for doing mathematical operations. And this is around when CUDA was born, which allowed developers to use GPUs for non-graphics tasks like financial modeling, physics simulations, and deep learning. Finally, from 2012 to today, deep learning really took off, and GPUs are now appearing everywhere since it's good for gaming, crypto mining, and scientific research. Basically, GPUs evolved from being image drawers to gaming, crypto mining, and deep learning monstrosities. Now, let's move on to talk about GPU pricing. As we mentioned earlier, there is so many use cases for GPUs that the demand for it is very high. And as basic economics would tell us, high demand means a higher price. In comparison to CPUs, as of April 2025, high-end GPUs like the RTX 5080 and the 4090, they can cost anywhere about $1,300 to $3,500, with similar high-end CPUs cost between $400 to $600 for the Ryzen 9 or the Intel i9. Another part of the reason why GPUs are more expensive is because GPUs are bigger chips, so it uses more silicon. Also, it includes a VRAM, which is much faster and also costs extra. Now, on the topic of use cases, now let's go over some ways in which you can make money with GPUs. First, we have renting out your GPUs for AI and ML workload. Like you can do this on platforms such as Vast.ai, Paperspace, and Genesis Cloud. Through this method, you can make around 20 cents to $1 per hour based on your GPU. Next method is crypto mining. You can mine cryptocurrencies with GPUs like Ethereum using software such as NiceHash, Compound Miner, or Phoenix Miner. It's somewhat profitable, and the main thing that you would need to worry about for this strategy is the cost of electricity. The next method is for rendering services, where many companies and services need to render new animations, 3D models, and visual effects which they all require GPUs to perform rendering jobs. And there are platforms you can rent out your GPUs for rendering capabilities to like the Render Network, Garage Farm, or Sheepit Render Farm. The final way to make profit from renting out your GPUs is through gaming or virtual desktop hosting. This method allows you to rent out your personal PC for remote gaming, and this could be done using platforms such as Parsec and Paperspace.